Hello, welcome to this video on simplifying rational expressions. In this first video, we're going to take a look at simplifying an expression and then simplifying the division of rational expression. All right, so our first example, we've got x squared plus 3x minus 10 all over 2 minus x. This one's already written as a single fraction, so our first step here is to just factor everything and divide out those common factors. So x squared plus 3x minus 10, if we try to factor that, we're looking for factors of negative 10 that add to a positive 3, and those factors that we're looking for are positive 5 and a negative 2. Since we do have the leading coefficient here is a 1, then those are going to be our factors, x plus 5, x minus 2. On the bottom, we've got 2 minus x. That's got the same numbers as one of the factors we just found, but all of our signs are different. This one has a positive x and a negative 2, where this one is the opposite. We've got the negative on the x and a positive 2. So let's factor out that negative in the denominator. So if we factor out a negative 1, that's going to be a negative 2 and a positive x. Well, that doesn't look the same, but remember, when you're adding and subtracting, it doesn't matter what order you do it in as long as the signs stay the same. And so let's rewrite this to x plus 5, x minus 2 over, and then I'm just going to switch these, rearrange it. I'm going to put my positive x out front and my negative 2 on the back. And now we do see that we have the exact same factor on top and bottom, x minus 2, so we can divide top and bottom by that common factor of x minus 2, and that's going to leave us with x plus 5 over negative 1. Dividing by negative 1 or multiplying by negative, we can put that negative really wherever we want, so I'm going to go ahead and pull it out front and write that as negative 1 times the quantity x plus 5. And then make sure you have those parentheses there so you know that you'll have to distribute that negative. Alright, so now let's look at this second example here. Here we have 8x over x squared minus 1 divided by the fraction 2x minus 4 over 8x plus 8. Now you might see this problem written like this. Another way of showing this exact same problem would be to take that first fraction and put it in the numerator divided by the second fraction in the denominator. So you'll see it in either form, either using that division symbol like we originally had on the paper, or in the complex fraction form where we have those fractions within the fractions. Either way, our goal is to write this as a single fraction, write it in something that looks kind of like the form that we started the previous problem in. And the way that we're going to do that is we are going to, anytime you're dividing fractions like this, you want to keep, change, flip. We're going to keep that first fraction exactly as it is. We're going to change that division to multiplication, and we're going to flip that denominator. This is the same type of thing sometimes you might have seen, you might remember, you multiply your outsides together and your insides together. If it's in that complex fraction format, it gives us the same basic idea. I'll point that out in just a minute. So we're going to keep that first fraction exactly as it is, 8x over x squared minus 1. We're going to change that division to multiplication, and we're going to flip that second fraction. So when we flip that second fraction, the 8x plus 8 that was in the denominator is now going to be in our numerator, and the 2x minus 4 that was in the numerator is now in the denominator. And you see that if we multiply the outsides together, that's the same thing we're getting on our numerators, and then when we multiply those insides together, that's what we're getting on the denominator. Now when we multiply fractions like this, really all we need to do is push it together. So we can rewrite this, or you might skip this step if you feel confident in it. This is one that's pretty commonly skipped. I'm just writing it as a single fraction. I'm putting each of our numerators and denominators inside parentheses so I can make sure and keep those factors together. All right, and now we're where we started our last problem, so we're ready to factor it. 8x, we can't factor it. We've got factors of 8 and x, and that's really all we can do with that for right now. 8x plus 8, however, we have another factor of 8, so we've got 8x times 8, and then if we factor an 8 out of 8x plus 8, we're going to get x plus 1. In the denominator, we've got x squared minus 1. That's a difference of squares. That's going to factor to x plus 1, x minus 1, and 2x minus 4. There we have a GCF of 2. And if we factor out, that's going to leave us with x minus 2 if we factor out that GCF of 2. And we have some common factors here. We've got an x plus 1 and an x plus 1 that'll divide out. We also have a 2 that can divide out one of those 8. So if we divide a 2 from the top and the bottom, then our 8 is going to become a 4, and our 2 is going to become a 1. All right, let's go ahead and multiply and simplify our numerator just a little bit. Those x plus 1s are going to completely cancel out, and so our numerator is going to be 8x times 4. Well, 8 times 4 is 32, and then we still have that x there. In the denominator, we're left with x minus 1, x minus 2. And that's all of our common factors. We don't have anything else we can factor out as a GCF and divide out, and so we are done. All right, I'll see you guys next time.